So now let's go a bit more into the detail of contacts, and we'll take an example here of a cylinder on a flat plate. There's all these complex models. But when it comes to contact, it's how you deal with these surfaces to get convergence as you want to and get the results that you need. So this has been slightly exaggerated for this picture, but if you take a look at the cylinder contacting the surface, you've got 3 ways we can deal with the condition that is on the screen. First of all, the default, if you don't make any changes inside the Design Studio interface, is to use the subtract padding option, but actually with a default value of 0, so no subtraction of padding. What that's doing is, if I've got these surfaces, is when it tries to converge, it is going to take the distance between the two surfaces at face value. So to find convergence, it's going to have to move the cylinder onto the surface at the closest contact point, and only through sufficient deformation will other parts of the contact achieve pressure in that contact definition. It's quite important to remember that Genesis's contact is a linear contact, so it does all of this checking in one single step. Unlike nonlinear solvers where they'll incrementally increase the force, it's putting it straight on in one hit and trying to find that contact condition. Secondly, if you want to negate that initial gap and you know what it is, then you're able to define here a padding distance to subtract, and that will remove that from any and all of the search distances, and it will start contacting from that distance. And then finally, it sounds a bit reckless, but you can just simply say ignore that gap. And so what happens is any surfaces that are within the search distance of the contact are considered to be immediately contacting at the point of movement. So if you take a cylinder on a flat, that's actually an example where it's not good to do that, because what it's saying is it sees the distance from where my mouse is currently down to the green surface as being in contact. So the pressure is going to be applied across the whole surface, which is not a representation of reality. However, that process is very useful, as you saw in the hook example, when you've got two discontinuous meshes as cylinders and you just want to model them together. And a key point is, just from a convergence point of view, this ignore option will typically solve an awful lot better than the other two. Okay, so I think, conscious of time on these settings here, I won't actually, no, I will dash briefly into this. I think it's important. It's always good to see how you progress through these webinars in the time available. So we'll just go to here. Here's our simple test, and actually if I do just zoom in, you can see in this particular example I've got this very small gap. It's actually just 0.1 of a millimeter, and if we look at the results we get, you start to get something that looks rather strange from a solve. It looks like we've got penetrations, if you can see that on screen. And the reason it looks like we've got penetrations is because the solvers had to actually move the red cylinder some distance before it starts to find contact and impact the beam. And the reason it looks a little odd here, and it's worth not panicking when you see this in contact analysis, is because our deformation scale factor is actually set to 62 times full displacement. So if I just explain that visually a bit more, if I set my scale here, which I can do via the options, to just 1, then if you start to zoom in and see what's happening, you can actually see that what's happening is Genesis has solved the initial gap and then the loading onto the bar. So that's your net displacement. And if I then just go very quickly into my contact data, and if I put in 0.1, which I know is this gap between the two surfaces, I can solve that again. take a little look. This time you see the actual contours are the same color this time. And it's looking much more like we'd expect it to see. And actually, if you notice, the bar itself is unaffected by this. So in this contact, I'm displacing 0.07. And in the first one, I'm also displacing 0.07. So it's just this displacement travel that we get. Okay,